I bet you'd just love for this discussion of derivatives to come to an end, and it is slowly coming to an end. But I wanted to make sure you got this concept completely clear before we move on, because we're going to be working with more complex equations, and we're going to be working with derivatives quite a bit in the days to come. And I don't want you to be confused at this point, because if you are, you're just going to keep being confused forever and forever. All right. Let's take an equation right here. We have 30 miles an hour, and we're going to divide it by 60 minutes. Now, we've got a road here. We're going to travel a total of 30 miles. And at the end of 60 minutes, we're going to go from point A, which is right over here, to point B, which is right over here. Okay, so from point A to point B, we're going to travel consistently for 60 minutes. All right, and if we can travel consistently for 60 minutes, we're going to travel a complete distance of 30 miles. However, let's say you're leaving some kind of a town and you're going to yet another town. Now, when you're driving in the first town, you may be going at 35 miles an hour. But then you hit some kind of a highway and you're driving now at 55 miles an hour. And when you reach the other town, you may be driving at 25 miles an hour. It's hard to believe, but there are some towns where you only drive 25 miles an hour. And that's true. So it doesn't matter that you're traveling 35 miles an hour for part of the trip, you're traveling 55 for another part of the trip, and you're traveling 25 for another part of the trip. The point is, you have covered a completed distance of 30 miles in 60 minutes. Okay? So, the average rate of speed for that kind of a trip can be found. You have 30 miles an hour, you're going to divide that by 60 minutes, and so basically it's saying you traveled a half mile every minute. Now, as we all know, if your car speeds up or slows down for any reason, you're no longer traveling a half mile a minute. Now you're traveling a different rate of speed. Okay, so that's your average speed. Your average speed changes based on whether you speed up the car, you slow down the car, weather conditions interfere with the traveling of your car, so on and so forth. But basically it comes down to, no, it doesn't matter why you had to slow down or speed up your car. Your average rate of speed of a half mile a minute will change because you had to speed up the car or slow down the car at a certain point in your trip. It's that simple. Now, here comes the problem. What if you wanted to calculate not the per minute rate of how fast you were traveling through the whole trip, but you wanted to calculate a number less than a nanosecond? Okay? Now, I know that they have names for numbers that are less than a nanosecond, but just to save a lot of argument at this point, okay, we're going to say anything less than a nanosecond is 0. Well, you can't divide 30 miles an hour by 0. Okay, you can't say, okay, we have traveled 0 minutes and 0 seconds. That means you haven't even gotten out of your driveway. So that's where the derivatives come from. We're trying to find that rate at less than a nanosecond. Alright, now I showed you in a previous video that the per minute rate and the per second rate and the per nanosecond rate can be, those numbers can be radically different. And that's based on a lot of divisions, it goes into a lot of hairy mathematical stuff. But the point is, we're trying to find a per less than nanosecond rate of traveling when you're doing 30 miles an hour. And that could be a tough number to find because remember, no number can be divided by 0. That is the equivalent of trying to divide a Thanksgiving turkey with no knife. That would be stupid. Okay. So, a couple videos ago, I was at Derivatives Part 4. We had a S5 here, which represented the distance traveled in the first 5 seconds of your trip. Okay? And then we had a little D here that represented an additional amount of distance that you traveled past the 5th second. So remember, every time you go from second 5 to second 6, second 6 to second 7, so on and so forth, you're going to travel an additional amount of distance. So we're going to use a variable, and in the first case we use the letter D to represent that distance that we just didn't know. Okay, we didn't know how much distance further we had traveled after the 5th second. And then we plugged it into here, and we had 5 seconds. We already knew we had traveled for 5 seconds. Now we have an additional amount of time that we have not been told about. Okay? We know we've traveled more than 5 seconds, but how much more? Did we travel 1/10 of a second more? Did we travel 1/100th of a second more? Did we travel a 1/2 second more? Did we travel 3 seconds more? We don't know. So we represented that by the letter E originally. And then we came up with this equation and we solved it, so on and so forth. Then, in my last video, derivatives part 6, or 5, sorry, this is part 6. Part 5, we said we're not going to use D and E as our variables anymore. We're going to use delta. Delta S here, delta T here. Delta S represents the amount of distance that you have traveled past the 5th second. Delta T represents the amount of time that has elapsed past the 5th second. It could be 5.1 seconds, it could be 6 seconds, it could be, you could have an additional second beyond the 5 seconds, you could have an additional 2 to 3 seconds beyond the 5 seconds. It doesn't matter. Delta T represents a period of time that has elapsed after the 5th second. Delta S represents a period. It represents a distance that you have traveled past the 400 feet or whatever you had traveled originally. Okay? And I'm going to continue on with this in the next video, so I want you to stay tuned. This discussion is just about over.